Materials that can interact with electromagnetic radiation based on their structure? That's so meta. I'm sorry, I had to, but we are talking about metamaterials today. Actually, we've talked about them before, and me talking about us talking about them is in fact meta. Okay, I'll stop. But I just figured that since it's been over 4 years, 3 sets, and 1 channel name change ago, we might look at them again and see where the field of metamaterials is now. First off, we should get a pretty firm grip on what exactly metamaterials are. Conventional materials interact with electromagnetic radiation like light or radio waves based on the properties of the material. We're used to how glass bends light or how gold reflects light and so on. And in our everyday encounters with these objects, we know what to expect because there's nothing special about these materials, usually. Unless some crazed engineer replaced them with metamaterials. Then things can get pretty unnatural. Take that gold, for example. You're used to seeing it all shiny and yellowish, and even on the nanoscale, that's still true for gold. Unless an engineer were to alter the surface of the gold, making nanoscale structures that changed how the light behaves. Then the gold could be green or red instead of the usual yellowish tint. Nothing about the gold's chemical properties have changed. It's still good old AU, atomic number 79. But the structures on its surface can change how we see it. These special structures take gold from a conventional material to a metamaterial. You might be more familiar with the concept than you realize. One Stanford engineer likens metamaterials to TV antennae of old. To adjust the image quality, you would wiggle the antennae around until the geometry interacted with the radio waves better. But the waves carrying TV broadcasts back in the day were centimeters to meters long, so the antennae that interacted with them were relatively big. If you want your materials to interact with electromagnetic waves that are microns to nanometers, then the shapes are going to have to be just a fraction of those wavelengths. You can start getting pretty creative with these nanoscale shapes. You could make lenses that don't rely on the material properties of precisely shaped glass to bend light, and instead use metamaterials whose geometry focuses the light the same way, but without the difficulty of shaping a lens, or the weight of bulky glass. With metamaterials, I could have glasses lenses that are 100 times thinner than a strand of hair, but still do the same job as these Coke bottle bottoms of mine. Or you could start mixing materials up to make different structures, or mixing structures up to control electromagnetic waves in any arbitrarily complex way you want. Obviously, this has huge implications for a lot of fields that deal with electromagnetic waves. For example, there are machines called synchrotrons, which use magnets to whip electrons around and around in a circle until they give off X-rays that are then used for various experiments. Synchrotrons are usually the size of buildings, but using 10 million precisely etched shapes in a lithium tantalate crystal, researchers were able to coax infrared light in a circle, causing positive and negative charges in the crystal that gave off terahertz radiation, waves that are between infrared and microwaves. The crystal was just half a square millimeter in size, but it was mimicking what you normally need a whole building to do. Magnetic fields can be manipulated with metamaterials too, and researchers at the University of Sussex just demonstrated a way to make one magnet connect to another without the other magnet connecting back, a magnetic diode. This could make wireless power transfer like cell phone charging much more efficient because power would only flow one way. And of course, light-bending materials open up the possibility of, wait for it, invisibility. But explaining how that works is a whole video on its own. Just know that with metamaterials, the possibilities really are only limited by how small we can make the structures and your imagination. Pretty meta. If you're interested in strange and unique sciences, subscribe to Seeker and check out this video on another way scientists are hacking nature. And fun fact before you go, metamaterials are only possible thanks to the same technology we use to make our nanoscale integrated circuits in today's electronics. Thanks for watching.